Hello YouTube fam. Welcome back to our channel. In this channel, we will be discussing various topics in the exciting world of AI, machine learning, and computer vision. Our content is crafted by our awesome human team, but here's the magic. It's finely tuned and optimized by our AI wizards, bringing you top-notch information. And guess what? The presentation is delivered to you by our AI hosts and voiced by our incredible AI avatars. Let's get started. In today's video, we will look at sleep detection using computer vision. This usually involves using cameras and image processing techniques to analyze visual cues that indicate whether a person is asleep. This technology has various practical applications across different fields. Here are some key use cases for computer vision-based sleep detection. Driver monitoring systems, healthcare and sleep studies, workplace safety, consumer devices for personal health, elderly care, security, and surveillance. The technical implementation primarily involves eye detection. A typical eye is made up of three main visual components like iris, pupil, and sclera, the gray, black, and white parts. When an eye is open, these features are clearly visible, but when an eye is closed, we do not see these features. We can use this concept for a simple sleep detection algorithm. For more details about RoboFlow and Ultralytics, please refer earlier videos. We thank them for the awesome technology and code samples. Here are the steps for implementing the code. You can refer attached Jupyter Notebook for more details. The YOLO fine-tuning training works well on GPU, and this was done on Google Colab with T4 GPU. Step 1. Generate video with eyes wide open. Step 2. Convert video frames to JPEG images. Step 3. Use RoboFlow to upload and annotate the images. Draw a bounding box and label the eyes. Step 4. Download the annotated dataset. Perform YOLO fine-tuning training using this custom dataset. Step 5. Run prediction on test video. Step 6. For each frame, parse the predictions. If eyes are detected, label the frame as awake. If not, label the frame as sleeping. Let us now see a demo of the sleep detection using computer vision. As we can see from the inference video, when the eyes are open, the model is able to predict the label as eyes and bounding boxes. Based on that, we tag it as awake. When the eyes are closed, the model is not able to predict anything. Based on that, we tag it as sleeping. Okay, that is it, folks. We discussed how to fine-tune a YOLO model and perform sleep detection using computer vision. Thanks for watching. Stay tuned for more exciting adventures in the world of AI and machine learning and algorithms. If you found this video helpful, don't forget to hit that like button. Subscribe for more tech talks and ring that notification bell to stay updated on our future explorations. Until next time, happy coding and keep the curiosity alive. Thanks for watching.